In this lecture, I will describe the psychrometrics. The name psychrometrics is given to a study of properties of air and water vapor mixture. Atmospheric air is considered to be a mixture of dry air and water vapor. The dry air is a mechanical mixture of oxygen, nitrogen, hydrogen, etc. However, the oxygen and nitrogen make up the major part of the combination. Dry air is considered to consist of 21% oxygen and 79% nitrogen by volume and 23% oxygen, 77% nitrogen by mass. Completely dry air does not exist in nature. If we consider the partial pressure of water vapor is Pw, that is the partial pressure of water vapor, and Pa is the partial pressure of dry air. Then by the Dalton's law of partial pressure, Dalton's law of partial pressure, Pw plus Pa is equal to P, where P is the atmospheric pressure. And from that concept, the mole fraction of dry air is Xa, that is equal to Pa by P, that is equal to Pa, because P is equal to 1 atmospheric pressure. Similarly, mole fraction of water vapor will be Pw by P is equal to Pw. Since Pw is very small and the saturation temperature of the water vapor at that particular pressure is less than that of atmospheric temperature. If we consider at that partial pressure Pw, the water vapor saturation temperature is T and atmospheric temperature is T atmosphere, then definitely T atmosphere is greater than that of T, and that is why the water vapor present in the mixture is superheated and the air is said to be unsaturated at the same time. Now, very important term, that is relative humidity. Relative humidity. Relative humidity, which is defined relative humidity, it is represented by phi, which is nothing but the ratio of partial pressure of the water vapor, that is Pw, in the mixture to the saturation pressure of a pure water at the same temperature of the mixture. Let me make you understand. If we consider this is the space, at any condition the water vapor pressure is Pw and the amount of water vapor is Mw, and temperature, suppose temperature is suppose T. At that temperature, suppose this air will saturated by amount of water vapor ms, and the partial pressure of the water vapor becomes Ps. So, according to the definition of phi, phi is equal to what? Pw by Ps, and that can be easily understood by Ts diagram. Suppose this is the Ts diagram, and this is the condition of the partial condition of the water vapor. Suppose this is the Pw, and this is the condition of the water vapor, and at that temperature, suppose this is the temperature, at that temperature, if the air becomes saturated, the saturation pressure becomes what? This. So, this is Ps. So, this Ps by Pw, sorry, Pw by Ps is relative humidity. Now, as we know that from the basic relation of Pv is equal to mRT, if we consider the water vapor behaves like a ideal gas, then we can write Pw into V is equal to Mw RT RH2O into T, and similarly Ps at saturated condition V is equal to Ms RH2O and T. The V is same because the volume of the room remains same and temperature also same. And from this relation simply we can find phi is equal to what? Pw divided by Ps, that is equal to what? Mw by Ms. Clear? So, this is the relative humidity. Now, another term is specific humidity. Specific humidity is represented by capital W. What is specific humidity? This is nothing but the mass of water vapor present per unit of mass of dry air in the mixture of the air and water vapor. That is, W is defined by the mass of the water vapor present per unit mass of dry air. That is, W is equal to m by G, where m what? M is mass of water vapor and G is mass of dry air. So, W is a specific humidity, m by G. Now, when W becomes maximum, the specific humidity becomes maximum when the air is saturated at that particular temperature. So, M becomes W becomes maximum, W max, when at particular temperature T the air becomes saturated by the water vapor. So, M when M becomes Ms by G. So, that is the maximum W, we can say W saturated. If the dry air and water vapor behaves like a ideal gas, we can write Pwv is equal to M is the mass of the water vapor, R W into T, and similarly partial pressure of air into V is equal to mass of air, R of air and T. And what will be the W? W will be m by g. Now, what is the m? If you put the value, then that will be Pw by Pa into Ra by Rw. If you put this value, Pw by Pa, what is the R? 8.3143 divided by 28.96 divided by 8.3143 divided by 18. This is the characteristic gas constant. Ra is equal to universal gas constant by molecular weight of the air, and Rw is equal to universal gas constant divided by molecular weight of the water. And we can write W is equal to 0.622 into Pw by Pr. Now, P is equal to Pw plus Pr. So, we can write W is equal to 0.622 into Pw by P minus Pw. So, this is an important relation. Clear? Now, when W becomes Ws, so what will be Ws? Ws matlab W saturated, that is W max, specific humidity becomes maximum. So, that will be 0.622 into Ps divided by P minus Ps. So, this is also an important relation. Now, another term, that is degree of saturation defined by mu. What is degree of saturation? Degree of saturation is nothing but mu is equal to W by Ws. That means specific humidity at actual condition divided by specific humidity at saturated condition. And very simply we can find W is equal to, we put this value W by Ws, then very simply we can find the mu is equal to, that means degree of saturation is equal to what? Pw by Ps into P minus Pw divided by P minus Ps divided by P minus Pw. So, this Pw by Ps is equal to what? Phi. So, mu is equal to phi into P minus Ps divided by P minus Pw. This is also a important relation. Clear? Now, when phi becomes 0, then mu becomes 0. When Pw becomes Ps, that means phi becomes 100%, then mu is equal to 1. So, we can say value of mu is varies between 0 to 1. This is also an important information regarding the degree of saturation. Clear? Now, next is what is the dry bulb temperature and wet bulb temperature. Now, what is dry bulb temperature? Dry bulb temperature is nothing but the temperature recorded by thermometer with dry bulb. If we consider this is the thermometer and this is a, suppose the mercury tube, this is the mercury tube. So, when we record the temperature of the thermometer with a dry bulb, that means simple, if we record the temperature by the thermometer, this is called the dry bulb temperature. Now, what is wet bulb temperature? Wet bulb temperature is recorded by the thermometer when the bulb is enveloped by a cotton wicks saturated with water. That means, if the bulb is around with a wick with saturated water, and if we record the temperature, whatever the temperature will be, this is the wet bulb temperature. So, dry bulb temperature, that is without any cotton wicks saturated with water, and wet bulb temperature, the temperature recorded by the thermometer with a cotton wick saturated with water. And why? And the wet bulb temperature always is less than that of dry bulb temperature. Why? Because as the air stream flow past it, some water vapor evaporates, and the taking the latent heat from this water soaked wicks, thus the decreasing its temperature. That means, whatever the water around this, whenever the air is passing through this, some water becomes evaporated and it will take the latent heat from this section. So, that is why the temperature going to decreasing, and that is why dry bulb temperature always greater than that of wet bulb temperature. Now, another terms is psychrometer, that means psychrometer. What is psychrometer? Psychrometer is an instrument which measure both the dry bulb as well as wet bulb temperature. Is that clear? So, psychrometer is the device which will measure dry bulb temperature as well as wet bulb temperature. Clear? Now, another important topic regarding this psychrometry, that is enthalpy of the moist air. To understand these topics, we required the TS diagram. Suppose this is TS diagram. This color is saturated liquid line, this color is dry saturated vapor line. Clear? According to the Gibbs law, according to the Gibbs law, the enthalpy of the mixture of a perfect gas is obtained by the summation of enthalpies of constituents. That means, if the mixture is drier and the water vapor, then the enthalpy of the mixture we can write H is equal to H air plus W into H W into H water vapor. Now, from where this equation is come? We can write this equation, that is G into H is equal to G into H air plus what? M into H water vapor, where H is the enthalpy, of the mixture per kg of dry air. It is not the specific humidity of the mixture. This is the enthalpy of the mixture per kg of dry air. So, if we divide this equation by Z, then we can get this equation. Let me make you understand what is the basic concept behind that. If we consider this line is reference line, suppose 0 temperature. If you consider this is the reference state, Suppose this is the reference state. So, this is reference state. Suppose this is 0 degree Celsius and this is the mixture condition. Suppose A. If we consider this A becomes through this line from here to here, then here to here, then here to here. So, at that point, what is the energy? That is equal to, if you consider this is V point. So, we can write H, we can find this HA and HW from this figure. How can? So, H air at that condition, what will be the enthalpy at dry air? HA is that is nothing but Cp of air into, if you consider this is the T, suppose a small t, then Cp into 2 T, because there is no phase change, air only change its temperature. So, Cp into T, because this is 0 temperature. So, Cp into del T, mCp dt, T, this is T minus 0. So, Cp into T, and we can get the enthalpy of water vapor following by this path, also following by this path. If we get this enthalpy following this path, what will be? So, HW will be is equal to H air, that is HA is equal to what? That will be is equal to, from this to this, that is sensible heating, Cp of water into T. If you consider this is point D, so this is Td, this is point D suppose. So, Td plus, from this point to this point, this is what? Latent heat, that is HFG at D, plus from here to here Cp of water vapor into T minus Td. And similarly, we can find out HW is equal to HB, that is equal to what? From here to here, HB is equal to what? HB is equal to nothing but HFG at 0 degree Celsius plus Cp of water vapor into T, because T minus 0 degree Celsius, that is T. So, finally, the equation, if we consider this equation, if we put this HA and HW in this equation, what will be the H? So, H will be is equal to H air plus W into H water vapor. So, that is equal to what? Cp into T, Cp into T, clear? Cp into T plus HFG at 0 degree Celsius plus CPV into T, with that there will be W. And we can write this equation, if we get common T from this and this, then what will be? T into Cp plus CPV W plus W into HFG at 0 degree Celsius. So, where Cp of air, sorry, this that will be Cp of air, that will be Cp of air, Cp of air. Okay. So, this is the equation. We can write this equation also, T into Cp, only Cp plus T into only Cp plus what will be W into HFG at 0 degree Celsius, where Cp is, what is the Cp? Where Cp is the humid specific heat, where Cp is the humid specific heat. Cp is considered as Cp air plus Cp of water vapor into W, that is the specific heat of humid air, clear, humid air. And by that way we can calculate the enthalpy of the mixture. And you may note down what will be the, Cp of water, that is equal to, Cp of water is equal to what? Cp of water is equal to what? We can write Cp of water just like .1868 kilojoule per kg, and Cp of water vapor is equal to 1.88 kilojoule per kg, and Cp, that is the humid air specific heat, that is equal to how much? We can write this, Cp is 1.0216 kilojoule per kg of dry air. You can note down this for calculate the numerical. I hope this lecture will help you to understand the basic concept of psychrometrics. Next lecture I will describe the psychrometric chart. Thank you.